Talk about link structures. Imagine this scenario. I'm in a library, and someone gives me a post-it with the call number of a book, in this case QA9.42. Inside that book, there is a post-it with the call number of yet another book, M.11. So I go get that book, and yet another post-it. I keep on following the call numbers until I get to a book with no post-it, at which point I basically reach the end of this so-called chain. Link structures are basically like this post-it call number chain, except more abstract. So instead of books, we have these things called nodes. And within each node, there is a data field, which is equivalent to the text of a book in this analogy. And a next field, which is like the post-it, tells you the next node to go to. And there's one final node without a next field, so the next field is set to null, like there's one book without a post-it. And as you can see here, a node object parameterized on type T has a data field pointing to an object of type T and a next field pointing to another node. And of course, this can be a lot to draw, so we'll just use this representation on the right instead. The left half of the node represents the data field, so it points to another object of type T, and the right half represents the next field, pointing to another node. Now, take some time to work through this exercise. Okay, so we have our first node, which has a data field pointing to the string Alice, and its next field points to the next node, with a data field pointing to the string Bob, and its next field points to the last node, whose data field points to the string Charlie, and then its next field is null, because it's the final node in the chain. Note that we cannot draw something like this red diagram down here, where there's a node pointing to two strings, because the way we define a node is that it needs to point to one string object and another node, unless it's the last node, in which case the next field is null, but we cannot have a node pointing to two strings. So link structures are a way to represent many ADTs. For example, a linked bag is a data structure that uses linked structures to implement the ADT bag. And we can take a look at a demo here. So we have the bag interface with several methods, and linked bag implements bag, and so it implements those methods but uses link structures to do it. And in a bit, I'll run some code that basically uses linked bags. And so we instantiate a new linked bag, and that should be empty. And so then when we try to get its size, that should return 0. But then say we add a string to that bag. Then when we query the size of the bag, we expect it to return 1. And then if you try to query the frequency of the string that we added, we'd expect that to return 1 as well. And so we'll run this and see what we get. Okay, so like we expected, we got the size of the empty bag was 0. The size of our bag after we added a string to it is 1. And then the frequency of the string that we added is also 1. So it works as we expected.